Microphone check 1 2. Microphone check. Alright, what's happening, everyone? Hope you rocked your quiz today. This is Monday night's video 5.3, and this is solving equations using square roots. So far we've solved equations. We solved quadratic equations, graphing them. We took a look at the x-intercept. And then we spent quite a few days on solving by factoring. Well, today we're going to solve by square roots. Now, let's take a look at some skills that we previously learned. First is simplifying radicals. Alright, so for instance, square root of 12. Now, there's two methods to do this. Some students like to pull out a perfect squares. Others of you like to make the factor trees. I personally like a factor tree. Alright, so if you break it down, you could go 6 and 2, 4 and 3, doesn't matter. Let's just do 6 and 2 because that's what came to my head first. And then 6 breaks down 3 and 2. You end your tree at each prime number. So perfect square match a pair. So I got a pair of 2s. Now each pair comes out of the square root as 1. Alright, and then whoever's left alone stays home. So root 3 stays in. Alright, the reason this is 2 times 2 is 4, and the square root of 4 is 2. So that's why it comes out as 1. That's the definition of a perfect square, some number times itself. So, perfect square, match a pair, whoever's left alone stays home. I make a rhyme every time. I'm a poet and didn't even know it. Alright, so the square root of 48. Let's try this one. Alright, now if you like, you could pause the video and try it. And then come back to my explanation and see how you do. See if you remember this. Alright, but if you didn't pause it, please take notes. So I'm going to break down 48. That's 6 and 8. 6 breaks down to 3 and 2. 8 breaks down to 4 and 2. Now 4 is 2 and 2, which is a pair of 2s. But if you notice you have a perfect square, you can stop there as long as you notice it. And we have a pair of 2s in this. Alright, so each pair of 2 come out as 1. So this pair of 2s down here comes out as 1. Those 2 together come out as 1. And whoever's left alone stays on the inside. And you multiply every individual, whether it be on the inside or outside, if they come out. So my simplified answer is 4 root 3. Now, what if I had something like the square root of 17? So la-di-da-di-da, go to break it down. 17, 1 and 17 are my only options. 17 is a prime number. If that's the case, it is fully simplified, and that's your solution. Alright, so that's simplifying radicals, and that's just a skill we're going to need in solving and simplifying our solutions. Now, there's 2 rules to follow when dealing with radicals. Alright, square root of a times the square root of b equals the root of a times b. So, the way I like to remember this is numbers with numbers, roots with roots. Alright? So numbers with numbers, roots with roots. So 2 times 8, because those are the numbers on the outside, equals 16. Then you have to multiply the root with the root. So root 6 times root 10 is the square root of 60. Now from there, we break it down. So 6 and 10, 2 and 3, 10 is 5 and 2. I got a pair of 2s. Now, you cannot forget about your 16 that's already out here. The pair of 2s comes out as 1. 3 and 5 are left alone, so they stay home. They get multiplied on the inside. So my simplified solution is 32 root 15. Alright, so that was rule number 1. Rule number 2 says if you got the square root of a over b, you can chop it up to say the square root of a over the square root of b. So, for instance, square root of 25 over 49 can be chopped up. It's root 25 over root 49. Those are both perfect squares, so that works out beautifully. Now, in the event they weren't perfect squares, let's say you got something like 2 root 5 over 10 root over 10. Alright, you could simplify numbers with numbers to be 1 root 5 over 5, or just root 5 over 5. So just a little side note when simplifying radicals. Alright, and the last skill before we get into the real noise is rationalizing. Rationalizing the denominator. And I spelled it wrong because I was too worried about saying it all funny. Denominator. Okay, rationalizing the denominator. Now, that's if you have something, for instance, like this, and we split it up. Now, there is no square roots allowed in the basement. Alright, so how do we get rid of that? Well, we take whatever that square root is, and we're going to multiply it by itself. Now, we're allowed to do this because root 5 divided by root 5 is really equal to 1. And multiplying anything by 1 doesn't change the value of it. We're just changing the appearance of it. It's kind of like we're getting a haircut. All right, we're the same person, we're just changing the way it looks. So root 3 times root 5 is root 15. And root 5 times root 5 is root 25, or a root times the root, as long as it's the same number, is always itself. So root 25 would simplify to 5. All right. Now, if you could, you would break down 15, but you get 5 and 3, and you get stuck. So you can't go any further than that. So root 15 over 5 is an acceptable answer. We no longer have a square root in the denominator. Alright, so that's a little review of all the things you need to know about radicals. You probably did some of it in geometry, some of it in Algebra 1. But that's what we got. So, now to the meat and bones of the lesson. Solving with square roots. And this is what we came here to do. Alright, but now with all those skills out of the way, we're probably only going to need about 1 or 2 examples to really get this accomplished. So, let's start with x squared equals 36. Now, many of you could look at this and right away we already know x is 6. Alright, but when solving, the inverse of a squared is a square root. So if we just have one x in the equation that happens to be an x squared, we can solve. Now, the very important piece is we can never forget that the answer is plus or minus the square root of 36. So my solution is actually plus or minus 6. Whenever you square root both sides, you always have to remember your plus or minus. And the reason is this. Think about this equation. X squared is 36. There's actually 2 solutions. Well, let's say x is positive 6. 6 squared, sure enough, equals 36. But what's negative 6 squared? Well, negative 6 times negative 6 also gives me positive 36. And this always occurs when you have a square. So whenever you square root both sides, you have to take that into account. Alright, so this is the biggest mistake you guys will make. You'll forget to put your plus minus, and you'll just put 6, and then you get minus a point because you actually only have one of the correct solutions, not both. Again, it all stems back to the graphs we started with. This parabola would cross my x-axis at 6 and negative 6. Alright, so it all stems back to our first lesson, but it's just different methods in order to get there. Alright, so let's try a little more difficult one. Let's look at 2x squared plus 1 equals 17. Now, our goal in solving this is we never square root to the end. So our goal is to get x squared by itself in a sense. Alright, so let's use inverse operations to get x squared by itself. So I'm going to subtract 1. And I get 2x squared equals 16. Divide by 2. X squared is 8. Now we square root both sides. Whenever we square root both sides, what can we not forget? Plus or minus the square root of 8. Then ask yourself, is this problem simplified? Well, 8 can be broken down to 4 and 2. 2 and 2, I have a pair of 2's. So x equals plus or minus 2. Whoever's left alone stays home. So that is my final solution. Alright, I got one more for you. And then I'm done. So I have 3 times the quantity, x minus 2 squared, minus 5 equals 15. Alright. Now, if you want, pause it, give it a try yourself, see how you do, and then come back and check your work. If you didn't pause, I'm still here. We're going to solve it together. Alright, now, this is my whole x squared term, so we got to get that by itself. So So I'm going to add 5. So I have 3x minus 2 squared equals 20. Now I want the squared by itself, so I'm going to divide by 3 and get rid of that piece. So I have x minus 2 squared equals 20 over 3. Alright, now at this point we have the x squared term by itself. So this is where I square root both sides. So I get x minus 2 equals plus or minus the square root of 20 over the square root of 3. Now, I'm not allowed to have a square root in the denominator, so I need to rationalize. So I get 20 times 3 is the square root of 60 over 3. And we need to break down the 60, which I think we did up above, so if you remember the answer, you can just use it. If you did it, I'm going to run through the steps real quick. So I get, oh, I can't read this, too small. So I get 3 and 2, 5 and 2, which gives me 2 root 15 over 3. Alright, so we got 20 root 15 over 3. I'm sorry, 2 root 15 over 3. So I'm just going to rewrite this with the simplified version. So x minus 2 equals plus or minus 2 root 15 over 3. Now, I still don't have x alone, so I need to add 2 to both sides. Now, this step is very important. It's important that the 2 goes in front, because we have 2 plus or minus 2 root 15 over 3. Alright, so that constant there goes in front of your plus or minus to give you your 2 solutions. Alright, we'll take some more time and practice this tomorrow. But until then, peace.